Is that what you're asking? There we can see the 45. Okay. I got to visualize it, okay, then to see it. Okay. Right. Yes. Yeah, it's always on you see I draw down here. Why am I pointing towards the board? Fracture surface orientation will always be at this point. It will rotate towards that point. Why? Because a chalk is what? Brittle. It can only withstand what sort of stress? Compression. It cannot withstand what sort of stress? Tensile. Be clear. That's why you will ask me, Eugene, why didn't it rotate this way? Yes or no? It won't rotate that orientation because chalk can withstand what? Okay. Yeah, don't worry. Okay. I want you to, I know this is a bit, if you were to ask me, this is like a gadget program. Okay, no. I want you to see this physically. Okay. On Monday, I'm going to buy 300 chalks. You are going to do the exact one. Same thing. Are we clear? Now, this will only work in what sort of material? Brittle material. In brittle material, this is always true. In ductile material, no. Okay? Right. So the next thing we're going to do, we're going to have fun with Mohr circle. Are you having fun with Mohr circle or you can't stand Mohr circle? Okay, Mohr circle. Right. So we are going to do a problem on Mohr circle. And the problem that I'm doing, can you all see the problem number? 9.67. We don't do Mickey Mouse stuff, you know. Now, again, we are going to read the question. Determine the principal stress. The maximum what? Can you see the word in what? In plane. So you know what is in plane now, yes or no? Right? You guys are seeing the term what? In plane now. Okay. The average normal stress, specify the orientation. So what I'm going to do in this example, okay, objective, okay. So the objective that we're going to do over here is this. The objective is we are going to translate information from the element to Mohr circle, and then we are going to bring it back into the what? Into the element. Because the element is the real world. Yes or no? What you saw earlier is all based on the element. We relate with Mohr circle. Are we clear? Okay. So now let's look at the first question over here. Okay. So we know that over here, we draw our orientation X, Y. Okay. And then immediately you have this question, yes or no? I uploaded. Okay. Then immediately you label this as your point X, and over here is your point Y. Okay. So from what we can see over here, we understand that stress X is equal to what? Positive 350 megapascal. And then we also know that stress Y is equal to minus 200 megapascal. And then we are aware that the shear XY is equal to our shear Yx and is under positive configuration at 500 times 10 to the power 6 Pascal. Okay, or megapascal. Okay, so from here we are going to construct Mohr circle. Okay, we are going to draw Mohr circle now. Okay, so I'm going to teach you how to draw Mohr circle. Okay, so on Mohr circle, I'm going to pick, I don't know what's the value to use, but I'm going to pick minus 500. Maybe 500 is too much. Okay, so minus 400, minus 300, minus 200. Maybe I can do, yeah, minus 200, minus 100, 0, 100, 200, 300, 400, 500, 600, 700. This is normal stress. And then on your shear stress, okay, so this is your shear stress. Okay, so shear stress, element rotating clockwise, element rotating anti-clockwise. So this is 100. Make sure the scale is the same. If the scale is different, you will not get Mohr circle. What do you get? Mohr over. Wow, this is minus 500. I think I need to go more. Minus 600, minus 700. And I think I need to go more like 800, 900. And I need to probably stretch this out. Okay. So this is minus 500, minus 600. Okay. Right. So this is the first time you have seen Mohr circle that has both normal stress and shearing stress combined into one. Yeah, repeat again. This is the first time. I do apologize. Okay. So this will be shear stress. Come on, Eugene. 600, 700. Okay. So you know that the normal stress is at 350. So we are going to sketch our normal stress line at 350 positive. So 350 positive. Somewhere over here. And then we have our compression at 200, negative 200. So we draw our 200. Okay, that's our negative 200. So this is our stress X, and this is our stress Y. Now our shear is at 500. Remember what I told you about shear? The shear, I can't pronounce shear all of a sudden. Okay, will be plus 500. And you also have to construct the what? Okay, now. No one do no writing. Watch this, okay? So we know, let's focus at point X, okay? Means point X, we are going to focus at the 350. Now the element is going to rotate clockwise or anti-clockwise based on this shear over here. Anyone? It will be rotating in an anti-clockwise direction when this is the case. Over here is your point what? X. And the other one, compression 200 going, the shear at 500 is going in a clockwise direction. Clockwise directions at the top. So this is your point Y. From here, you can immediately construct, you can draw a straight line. That is the first thing that you draw. Okay. The sequence of solution is very fixed for Mohr circle. Once the most important thing is these two lines, or these 2 points and this straight line. then you use very fundamental equations or very fundamental math. I think grade 10 student could do it. Okay. Grade 10 student could do it. Is how useful it is. So what are we going to calculate first? The first thing we're going to calculate is going to be our center of circle. And the center of circle is known as stress average. So this will be equal to stress X plus by stress Y divided by 2. Okay. So we know that stress X is equal to 350 plus by minus 200. Remember, stresses are vectors. So this will be equal to 150 divided by 2. Is it 150 divided by 2? 350 is equal to positive 75 megapascal, which is correct over here now. Okay, so now we know that this is the center of the circle. Always remember, circle is a beautiful thing, okay? And you can see we are smack on, and we are going to label this as point O. Okay. So the next thing that we're going to find is known as the radius of the circle. Okay. And the radius of the circle happen to be our tau max also. So how do we find our radius of the circle? Straightforward, not difficult at all. All we need to do now is to find the distance from here to here. And this distance is equal to what? 500. Okay. And then the next thing that we need to determine is the distance from the stress average, the green line. Okay. So this is 350 minus by 75. So it's equal to 275. Okay, that is equal to 275. Okay, so from here, tau max will be equal to 500 squared plus by 275 squared. And this will be equal to 500 squared plus by 275 squared. Square root of the whole thing is equal to 570.63. 570.635. So from here, once you know all this value, you can calculate your principal stress. Okay, you can calculate your principal stress. So at the principal stress, you know that the shear stress is equal to 0. So now we can determine our stress 1 and stress 2. It's basically your stress average, which is the center of the circle, plus minus by tau max. So in terms of English, this is equal to the center of the circle plus minus by your what? By your radiuses. From here, the center of the circle is equal to 75 plus and minus by 570.635. Okay, let me calculate again. 500 squared plus by 275 squared, square root the whole thing, 570. So 75 plus by 570.635 is equal to 645.635 positive. And the other one is 75 minus 570.635 is equal to minus 495. Minus 495.635. So what we have done now is we have determined 2 points. Okay, 1 point, which is 645. I'm eyeballing this. This I call my stress 1 value. Okay, and the other one is minus 495, 75 by 570.635, 495. Okay, so this is my stress 2. Okay, So from here, we know our maximum shear stress is what? Maximum shear stress is 570. So I'm just going to eyeball the 570. So 500, 570 is here. Eyeball this 570 is somewhere around here. Okay. So from here, you use your mathematical set and you draw your what? You draw your Mohr circle. I have to draw my this way because I don't know how to use the function of the, I mean, I found this is the best way of drawing Mohr circle on a computer. So you stretch this out using your mathematical set. Okay. So this Mohr circle is for your X, Y plane. Okay. Class, meet Mohr circle, meet the class. Clear? Is it difficult? No. Okay. So once you get this Mohr circle, we can do wonderful things. Are we clear? Okay. Have a good weekend. Don't die. Be safe.